Hello guys, welcome to the DMS online school. If you're new to this channel, you are most welcome. And on this channel, I offer online tuitions for science, biology, civic education, English, RE, and mathematics. So in today's video, we are going to do a revision on a topic known as the organic chemistry in chemistry. So if you're new to this channel, you're most welcome, and remember to click the subscribe button below so that whenever I upload a new video, YouTube will be able to notify you. And remember to like, comment, and share the video. So without further ado, let's go straight into this revision. So we have this question 10, which came in a particular paper in 2011, and this question came under section C. So the question reads, crude oil is an important raw material that we need in modern life. Engineers process and refine crude oil in a tower to produce a number of fractions as shown in the diagram below. So we have this diagram here, which is known as a fractionating tower. Then we have different fractions that are being separated from hot crude oil in. Then out of here, we have fraction A. Then we have petrol. Then we have fraction B, diesel, lubricating oil, fuel oil, fraction C, and then fraction D. Then A, the question reads, name the process used to separate the fractions of crude oil. So, before answering, we shall look at the different fractions that are produced here. But we'll do that just in a moment. Let's first read the remaining of the questions. B, name the two major elements that are found in crude oil. Then C, state two differences in physical properties between fractions extracted at C and B. So, let us first of all, just as I said, look at fractions which are separated from crude oil in this fractionating tower. So the first fraction, which is separated here where I've put the letter M, is refinery gas, also known as petroleum gas. Sometimes they abbreviate it as LPG, which is liquid petroleum gas. The next we have petrol. Then after petrol we have naphtha. After naphtha, they made a mistake by putting diesel here. We are supposed to have paraffin or kerosene. And then after kerosene or paraffin, we are supposed to have diesel gas oil here. Then after diesel gas oil, we are supposed to have fuel oil, then fuel oil lubricating fraction, and also we are supposed to have bitumen here. Okay. So these are the different kinds of fractions which are separated from crude oil. Now let's go straight into answering. A, name the process used to separate the fractions of crude oil. So the process which is used to separate these fractions is known as fractional distillation. Fractional distillation. Then let's move to B. Name the two major elements that are found in crude oil. So the major elements that are found in crude oil, since crude oil is a mixture of hydrocarbons, and hydrocarbons are organic compounds that consist of carbon atoms and hydrogen atoms only. This entails that the major elements that are found in crude oil are actually carbon and hydrogen. When we go to C, state two differences in physical properties between fractions extracted at C and B. So we have to name or or state two differences in physical properties between fractions extracted at C and B. So in answering, the differences are one, we have fraction C has a higher boiling point than fraction B. So fraction C has a higher boiling point than fraction B. Then the second difference is that fraction C, this one here, is more viscous or thicker than fraction B. So fraction C, which is lubricating oil or fraction, is more thicker than fraction B, which is naphtha. Let's move to the next question. The next question D says, a large proportion of fraction A has the molecular formula CH4. A large proportion of fraction A has the molecular formula of CH4. Write a balanced chemical equation for the complete combustion of the compound with chemical formula CH4. So we'll go right away in answering. So a fraction which is mainly found in fraction A with a chemical formula CH4 is methane, and methane undergoes the process or the reaction called combustion when it reacts with oxygen. So when methane reacts with oxygen, produces water and carbon dioxide. So this is a chemical equation. When you're writing a chemical equation, you write it using chemical symbols and chemical formulas of atoms. So methane reacts with oxygen to produce water vapor and carbon dioxide. The question says we balance the equation. So in balancing, we will look at the number of atoms on both sides of the equation. When we look at the left side of the equation, the number of carbon atoms is 2, is 1. On the right side is 1 as well. So with carbon atom, the number of atoms are the same. We come to hydrogen. There are 4 hydrogen atoms here because of the 4 down here. On the right side, we have 2 hydrogen atoms. So with regard to hydrogen atoms, they are not equal because this side we have 4 hydrogen atoms, while this side we have 2 hydrogen atoms. To make them balance, we'll add a 2 here, so that we have now 2 times 2, 4 hydrogen atoms, which makes the number of hydrogen atoms equal on both sides of the equation. Then we move to hydrogen. We have 2 hydrogen atoms. When we come on the right side of the equation, we have 2 hydrogen atoms here plus these 2 hydrogen atoms here, which makes them total on the right side of the equation. So on the left side, we have 2 hydrogen atoms. On the right side, we have 4. So with regard to the number of hydrogen atoms, they are not balanced. So what we are going to do to make them balance is to put a 2 here, which will make the number of hydrogen atoms, oxygen atoms, 4. So 2 times 2, 4. Then we move to E. E says crude oil is a non-renewable energy source. Crude oil is a non-renewable energy source. Explain what is meant by a non-renewable source. Crude oil is a non-renewable energy source. Explain what is meant by a non-renewable source. So in answering, you have to understand that a non-renewable source is an energy resource that cannot be replaced within a human lifetime once it is used up. So in other words, a non-renewable energy source is a source of energy which cannot be reused once it is used up. For example, coal, petroleum, these are examples of non-renewable energy sources. Then we move to question F. Question F says, give two reasons why the sun is a better source of energy than crude oil. Give two reasons why the sun is a better source of energy than crude oil. So here are the two reasons. One, the sun is a renewable energy source, while crude oil is a non-renewable energy source. Then two, solar energy produces no pollution when used, while burning crude oil produces carbon dioxide and other pollutants when used. So this is what it is here. Now, to do a quick recap, we have to look at crude oil. For you to understand the topic, you have to look at the crude oil. Crude oil, also known as the petroleum. So, what is crude oil? Crude oil is a complex mixture of hydrocarbons, mainly alkanes, cycloalkanes, and aromatic hydrocarbons that is extracted from underground rocks. So crude oil is actually the source of all different types of oils that we use, or fuels that we use in this world on earth. So what we should know is that it is not a single substance. Crude oil is not a single substance, but a mixture. A mixture of what? It means it contains many hydrocarbons with different chain lengths. So it's very important that you understand to say hydrocarbons are molecules made up of only hydrogen and carbon atoms. Hence, crude oil's many elements are carbon and hydrogen. All right. So you need to understand also that its composition makes it flammable, making it a useful source of fuels and raw materials for industry. All right. So now let us look at the geological location and formation of crude oil. Where is crude oil actually found or formed? So in understanding this, we are saying this crude oil we are talking about is found in sedimentary rock basins under impermeable rock layers that trap it, as shown in this diagram. So these are the rocks, okay? This up part is called an anticline, and then under the anticline we have a reservoir rock here containing oil. Here you can have gas, and here you can have water. So this is how it is found, trapped. So you can have gas, oil, and the water. So that's where crude oil is found, under the ground. Okay, so we have to understand that this crude oil formed millions of years ago from the remains of microscopic marine plants and animals that were buried under mud and sand. So this implies that all the animals, all the plants that lived million years ago, as we speak now, they have turned into crude oil. So crude oil, which is processed to produce petrol, came from living things which lived a long time, million years ago. So you and I must remember that when we board a car, when we board a bus or an aeroplane, we are using fuel which came from living things like us. So what happened? These living things, they died and were buried under the mud and the sand. Like in this diagram A here, we have underground of water, stagnant water like in the ocean, underground of it, or we have organic matter and drip. With time, what happens is with the sediments, more materials coming on top of these become compressed peat. With time, they change into ignite core. So this part here, sediment becomes sedimentary rocks, and these they go down there to be compressed, to be melted, and with time, bituminous core and also crude oil is formed. All right. So we also must understand that with high pressure and temperature and absence of oxygen, these remains were chemically changed into hydrocarbons. So high pressure, temperature, and absence of oxygen caused those deadly animals and plants which were buried under mud and sand to be chemically changed into hydrocarbons. Okay, now let us talk about extraction of crude oil. Once crude oil is found underground, trapped in sedimentary rocks, what is next? What is next is extracting it, which is extraction of crude oil. So here we must understand that crude oil is extracted by drilling oil wells into oil reservoirs. So those oil reservoirs, those places where crude oil is trapped from, are the one we are calling as reservoirs. So what happens to extract this crude oil in the sedimentary rocks here? Drilling is done of the earth. So drilling machine or holes are drilled into the soil until crude oil is reached. Okay, so these are two scenarios that I'm giving, which just means the same. So what happens? Once it is drilled and found, it is pumped to the surface using rigs. So they pump it to the surface. Now what happens next? What happens next is that this crude oil is transported by pipelines, so they can either use pipelines, tankers, or ships to refineries. Okay, so in this diagram, we are illustrating the process of crude oil extraction and the transportation. So if this is the place where crude oil is extracted, it can be transported or refined just here. Here we can see that it is transported, it is extracted actually using the ships. Here we are seeing a tanker that is being used to transport this crude oil to a different place where it can be refined from. From after refining, then it is taken to the places where it is sold from. So next now, we look at the refinery of crude oil. Once it is extracted from the ground, the next step is to refine it so that it can be used for the purpose it is extracted for. So what is involved in a refinery of crude oil? Crude oil on its own is not directly useful because it is a mixture of substances with different boiling points. So refining, which is done by fractional distillation, helps to separate crude oil into useful fractions that can be used as fuels and raw materials. So here, refining of crude oil takes place in a plant called the fractionating tower. All right, so Crude oil refining takes place in a plant called a fractionating tower. So this diagram illustrates what can be known as a fractionating tower. Like this part here is a fractionating tower, and this part here is a fractionating tower. As crude oil is extracted, it can be taken to places here where it can be boiled and be taken into those. So these are places where crude oil can be mined or extracted from. Okay. Now, let us look at stages in the refinery process. So, the first stage is that crude oil is heated in a furnace until most of it evaporates. So, crude oil is heated in a furnace like here. Crude oil put in a furnace and heated until most of it evaporates or vaporizes. What happens next once it is vaporized? The hot vapor enters the bottom of the tower. So the hot vapor enters the bottom of the tower, and this is a fractionating column here where fractional distillation of crude oil occurs. So fractional distillation is the process used to separate materials that have different boiling points. So it is a process that is used to separate a mixture of substances due to their differences in boiling points. So once crude oil is heated to vaporize it and it enters the bottom of the fractionating tower, the next thing is that the column is hotter at the bottom and cooler at the top. So the column, as you see it, this one here, it is hotter at the bottom and then cooler at the top. So different hydrocarbons now condense at different heights based on their boiling points. So as they are pushed into this fractionating column, those hydrocarbon fractions begin to condense from actually gas to either liquid or solid at different temperatures according to their different boiling points and melting points. So here we understand that shorter chains condense at the top. Those with low boiling points will condense at the top there. Okay. Then longer chains condense at the bottom, high boiling points. So those with high boiling point will condense at the bottom here. Okay. So now, after looking at that, now separation of fractions of crude oil is made possible because of differences in boiling points between fractions or components of crude oil. So what makes it easier for separation, just as we mentioned, of the fraction of crude oil is the fact that each of the fraction here in crude oil contains its own physical property such as boiling and melting point. Okay, so let us look at uses of fractions of crude oil. Let us look at uses of fraction of crude oil. So in this fractionating tower, we are now going to look at the fractions which are separated and their uses. So at the top here, the fraction which is produced is refinery gas, which is used as fuel. So this one can be used as fuel in lamps, okay, even in gas stove and so forth and so on. Then the next fraction, which is produced at stage 2, stage 1, stage 2, is known as gasoline or petrol. So gasoline or petrol is used as fuel in cars, okay? Then the third one produced here is known as the naphtha. So naphtha is used to make chemicals. It is actually used as a chemical feedstock for making other industrial materials such as plastics. Then the fourth material produced here is kerosene or paraffin, which is used as fuel in jet engines. When you hear about jet fuel, then we are talking about kerosene and paraffin. Long time ago, when we were young, when we were asked to mention the type of fuel used by aeroplane, we only knew the type of fuel being used in aeroplane as benzene. But as I have come to grow now and understand chemistry, I've realized that the type of fuel which is used in aeroplanes is called jet fuel. And in this case, it is kerosene or paraffin. Then the fifth fraction which is produced here is known as diesel oil or gas oil. This diesel or gas oil which comes out from here is used as fuel in diesel engines such as trucks, buses, etc. Then the sixth one is actually known as the fuel oil. So this fuel oil which is produced here is used as fuel for ships and for home heating systems. Then the seventh one produced here is known as lubricating oil, which is used in waxes and polishes and also used in lubricating machine parts such as the engines. Then the last one produced here is known as bitumen, even when we called it residue here. This bitumen produced here is used to make bitumen for road surfaces and also roofing. So, in form of a diagram, this is how these different fractions are produced from this fractionating tower here. All right, and now let us look at the table here. Now, this table also contains the same fractions that we have looked at. Refinery gas, in terms of molecular size, it contains hydrocarbons with carbon atoms from 1 to 4. Main use, as we said, for fuel, refinery heating, then liquid petroleum for cooking or heating, also used as petrochemical feedstock. When we come to petrol, gasoline, it is used as car fuel and also solvent. When we come to naphtha, it is used as petrochemical feedstock for plastics and also for industrial solvent. When we come to kerosene or paraffin, it is used in jet fuel, heating fuel, lamp fuel, rocket fuel. When we come to diesel or gas oil, it is used in diesel engine fuel, as diesel engine fuel in cars, trucks, and trains. It is also used in heating oil and also marine fuel. Okay. Then when we come to fuel oil is used in ship as fuel, also power station fuel, also industrial heating. When it comes to lubricating oil is used as engine oil, machine lubricants, and hydraulic fluids. Then when we come to this one, bitumen or asphalt, this one is used for road surfacing, roofing materials, and waterproofing. Then we move on to the last part, where now we are going to look at key property trends in fractional distillation. When we talk about key property trends in fractional distillation, we are talking about the properties that you observe as you move from top or as you go down the fractionating tower. So what are these? The first one is boiling point. So as you go down the fractionating tower, boiling point increases. So why? Larger molecules need more energy to separate them, because as you go down, the molecules become larger or bigger. And because they become larger and bigger, you need more energy to separate them. Hence, uh, hence boiling point increases. Then secondly, viscosity increases, meaning that longer molecules tangle more, flow less easily. So as you go down, molecules begin to flow less easily, meaning that viscosity increases. Then the next one is volatility. So we are saying volatility decreases, meaning that larger molecules are less likely to evaporate. So volatility is the ability to do what? The ability to evaporate easily. So as you go down the fractionating tower or the fractions, you discover that the volatility decreases. Then flammability decreases as well as you go down, meaning that larger molecules are harder to ignite. Okay, then molecular size increases, meaning the size of the molecule increases down the fractions. More carbon atoms per molecule. That is the reason, because there is more carbon atoms per molecule. This is why lighter fractions that are on top of the tower are used as fuels, while heavier fractions, those at the bottom tower, are used for lubrication and the construction materials. Well, we have come to the end of this chemistry quick revision. If you enjoyed it, remember to like the video, comment in the comment section, and also share to other people and subscribe. And for those interested in online tuitions, you can WhatsApp me on 0977 92 41 75. 0977 92 41 75. For now, guys, bye and see you in the next video.